Hey guys, how's it going? So in the last video, we introduced the idea and fundamentals about the atom. We talked about electrons, protons, and neutrons. And I wanted to talk about properties of atoms, such as atomic radius throughout this video, but one thing I realized is that we gotta talk about electrons. The way we portrayed them in the last video were fixed points, with the Bohr model. But this isn't true at all, even further from the truth. Electrons fill up a space, a probability that we map out around the nucleus, depending on their energy. So throughout this video, we're going to talk about and introduce the atomic orbitals. There's a lot of mathematical properties and complex ideals when talking about the orbitals, but I don't want to focus on that throughout this video. I want to focus on conceptualizing what they are so that moving forward when we refer to them, we understand what we're talking about. We talk about the electron in reference to the nucleus. We talk about something called electron probability. It's because the probability of finding an electron around the nucleus of an atom. The atomic orbital is just a geometric shape to map that probability at that energy level. So we have different energy levels, and at different energy levels, we're going to have different sizes or different types of atomic orbitals. There's s orbitals, p orbitals, d orbitals, and f orbitals. But throughout general chemistry, we're just going to focus on the chemistry and interactions of s and p orbitals. Throughout this video, you've heard me mention the phrase energy level a lot. That's because as we go down the period of the periodic table, we increase in energy level, starting from 1, and usually these energy levels are designated with the letter n, the principal quantum number. But I won't get too much into that with this video. So starting with 1, we go 1, 2, 3 as we go down the periodic table. So the group with hydrogen and helium is in the n=1 energy level. But as we go down to lithium and later beryllium, we're talking in the second energy level. And this continues down the table. Different energy levels or n values have different capabilities of entering different atomic orbital types. So at the n=1, we just have the s orbitals. But at the n=2, we introduce the p orbitals. So now when we're at that second energy level, we have the possibility of being in the s and p. At the n=3, we introduce the d orbitals. And then finally at the n=4, we introduce the f orbitals. But we're just going to be focusing on the s and p. After that real dense introduction to atomic orbitals, it's ready for us to talk about how we fill electrons into these orbitals. One thing we got to know is that each of these orbitals can hold 2 electrons. So as we start filling them, we put 2 electrons per orbital type. So starting off with hydrogen, we're going to have 1 electron in the 1s orbital. 1 representing the energy level and s representing the energy type. Since there's only 2 atoms in that first period, hydrogen and helium, then the electrons that we're playing with are going to be belonging to the s orbital, the 1s orbital. So where hydrogen has a 1 electron in it, helium has 2. And I know that's kind of confusing. How can 1 atomic orbital hold 2 electrons if they're both negatively charged? Wouldn't they repel one another? This is where we start talking about the Pauli Exclusion principle. We can have 2 electrons in the same atomic orbital because they have different spins, opposing spins, that cancels out their magnetic fields. So we have 0. And so moving forward, we're going to start filling in the electrons. So after helium, now we're talking about lithium. Lithium is going to introduce the second energy level. Since the s orbitals can only hold 2 electrons, after we filled the 1s, we're going to start moving to the 2s. I know previously I talked about that the p orbitals get introduced in the second energy level, but there's a reason why we start filling in the 2s before the 2p. This goes down to talking about that different orbital types have different energies. Remember that I mentioned how an atomic orbital is just a geometric space of the probability of finding an electron. Well, in certain orbitals, we have what is called a node, where the probability of finding the electron is 0. the more nodes an orbital has, the higher in energy it is. So the 1s orbital, the one that we talked about with hydrogen and helium, has no nodes. The 2p orbitals have an innate node. Now there is a node between the 2s and the 1s, but that's a little different. The type of orbital s is lower in energy than the p. So as we start filling in electrons in our second energy level, we're first going to start off with the 2s and then work our way over to the p. So the first electron is going to get filled in at the 2s from lithium, then it's going to get paired from beryllium, and then we're going to start filling in the p orbitals. This can definitely come off tricky at first, since there's 3 different types of p orbitals within the second energy level, and that's because of the angular quantum number. I'm not going to go too much into it, but this number represents the orientation in which the orbitals can be in, and it's kind of dependent on the nth value, or the energy level. As we increase, we open the probability of different orientations. So with the L equals 1, we have 3. The L equals 2, we have 5 with the d orbitals, and the L equals 3, we have 7 with the f orbitals. So for the 3 p orbitals that we have, each one of those can hold 2 electrons. So for any energy level, we have a total of 6 electrons that belong to the p orbitals. Okay, so let's take a breather. I'm sorry. If you're just learning about chemistry, this is a very dense video, learning about orbitals and electrons. But don't worry, throughout learning about chemistry, we're going to constantly refer to these topics. So they're definitely going to be reinforced. And it's really beneficial moving forward that we introduce them now. So let's kind of summarize what we were talking about. We have different energy levels that represent the size or the energy value of the atomic orbitals. As we go down the period and increase in the energy, we get introduced to different orbital types. We know that electrons can be paired within the orbitals because each orbital can hold 2. But we haven't talked about one principle. We haven't talked about the Hund's rule. Even though electrons can be paired, it takes energy to pair them. So when we have the option to, we're going to fill each orbital with 1 electron in the same spin state until we start pairing them. This is because it takes a little bit of energy to pair the electrons. So as we can see here with this animation of nitrogen, it's filling in the electrons. So we put 1 in 1s, we pair it. We put 1 in the 2s, then we pair it. But since there's 3 2p orbitals, we put 1 in each of the 3. But as we can see with oxygen that has 1 more electron than nitrogen, one of those p orbitals is paired because we filled each of the 3 with 1 electron and then we paired it. This process of filling electrons or electron configuration is represented in many different ways. One way is with the arrows, how we see here with nitrogen and oxygen, and another way is writing them out. You're probably going to have to write them out and do the arrows when you do exams for chemistry. So when we're writing them out, we got to make sure to fill in the lowest energies first. So for nitrogen, we have 1s2, 2s2, and 2p3. For oxygen, we have 1s2, 2s2, and 2p4. So as you can see, some of the atoms are definitely going to have long configurations. This is why we also have like a shortcut method that we only focus on the valence shell. We reference the previous noble gas, and then we move forward. So remember, the valence shell is at highest energy level. So for both nitrogen and oxygen, it's going to be 2. So we will reference helium. Moving forward, we're definitely going to talk about these concepts a lot more. I just wanted to have a video just introducing them for someone who's just starting to learn about chemistry. So I hope this video was helpful, at least introducing you to the idea of atomic orbitals. And what would mean a lot to me is that by the end of this video, you just understand that electrons aren't fixed around an atom. So remember, all these educational infographics that you see throughout this video are for free download in my website. And then in the following videos, we're going to talk about properties of atoms. And I wish you a great day.